Sì. Perché quando si spegne si deve...
Sentite bene in fondo?
Pronto, pronto? Alziamo il volume? Diciamo che lo alziamo. Aiutami. Ah, ecco, qui davanti. Adesso va meglio? Sì.
Partiamo?
In inglese? Sì, sì, sì. In inglese.
Fantastico.
Yes.
Okay.
Yes.
Good afternoon. Good afternoon, everybody, and welcome. Welcome to the Physics Colloquium. This series of seminars is generously sponsored by the Department of Physics at the University of Genova and INFN. This program brings together world-leading experts in their fields to tell us about the status of their fields. Today we have Elisabetta Vignati.
Good afternoon, also from me. Just 2 words to introduce our speaker. Dottoressa Elisabetta Vignati, she's a physicist. She got her master in Milano so far, then got a PhD in Copenhagen,
Yes.
right? And after then, she entered basically to work in the Institute of the European Union, a research institute of research of the European Union. Her field is air quality, climate. She started working on modeling of phenomena which determine the climate, for instance, at global scale. And she developed her career in this institute from several years. Is an important position in this institute since she has head of a unit, I don't remember exactly the name.
Clean Air and Climate.
Clean Air and Climate Unit. She's deputy director of the Directorate on Energy, Mobility and Climate for the European Commission. So she is in the best position to link the status of the research in this fundamental field and the policy makers, people who decide on our life. So it's very important to describe how the scientific work, the research work can impact on common people. And so thanks, I'm very happy to have Elisabetta here, and I give you the floor. Thanks so much.
Thank you. No, I don't need this.
Okay.
Good afternoon, everybody. It's really a great pleasure to be here today. I'm not so used to have such an audience in the vertical, really typically of a university, and it is really something that warms my heart to see all of you here and interested in something that I'm going to say. I want to thank also Paolo for the invitation. This invitation is even before COVID came, so we had to wait quite some time to have this event happening, and therefore this is also of more importance for me. Paolo mentioned already that I work in a peculiar place because I'm a researcher as training, but I've been not doing research myself already for 12 years, leading our group really working on the research related to air quality and climate change, particularly the mitigation part. But the place I work is really peculiar because it is within the European Commission. So our role is really to work on the interface between science and policy. And that's why I decided to come and talk to you about this, and particularly related to one of the most controversial issues from the policy point of view, which is really climate change. So before moving into the seminar, I would like to tell you a few words about exactly where I work, because this is now it doesn't work any longer. Let's see. Let me see, like this. Yes, thank you. So to tell you why I came here to talk about this. So few words about where I work, which is called the Joint Research Center, is one of the Directorate General of the European Commission. It is actually the only Directorate General that actually can do science. But of course, we don't work like a university, so we don't work on basic science, but we work on the science that has an impact on the policy. And in fact, we are one of the parts of the compartments of the European Commission per se. So Ursula von der Leyen is really my highest boss in the organization. The Joint Research Center is composed by around 3,000 people divided into the fields of science that you can see in the bottom of this slide. And then we cover from economy, financial, energy, mobility, climate, sustainable resources, nuclear, decommissioning, and other things. So we cover really a broader spectrum of the research, but as I said, not to mimic or to duplicate what is done in the university, but really focusing our attention on specific issues that are of interest of the policy per se. So you know, you have heard that during the current Commission, the European Green Deal has been among the core of the political actions. Now, this year, in a few weeks, we are going to have the new Parliament election, European Parliament election, then the new Commission will start, then the new priorities will start, and then we'll see also where the JRC will have to intervene. And under the mobility, energy, and climate, there is our unit. Our purpose is really to focus on giving the technical and scientific information to the other DGs, as I said, the other Director Generals, which are the ones writing directives, communications, writing recommendation, writing the European law. So we don't work on the law ourselves, but what we do is really giving our scientific input to them. And then we will come to this because the last part of this seminar will be about what we have done in the development of the recent European policy about the climate action. And actually, I wanted to do some scouting because you probably don't know, but one of the sites of the European Commission and the Joint Research Center is not so far away from here. Actually, it is in the Varese province, so it's a beautiful place. And then this is one of the 5 places where we do science while our headquarters is in Brussels, together with the other DGs. And then I want to conclude this inviting you really to look at our website where all the work that comes from us is publicly available. So you find there the databases, the research we do, you find all the publications that they are there, and most of all, you find also the open positions. If you would like to dedicate your time and your career in a place where indeed we look particularly to the scientific topics that are important for the policymaker. Said that, let's start with our seminar. And then I tell you what this seminar is not about. This seminar is not about convincing you that the climate change is happening. It's not about providing you the physical or chemical details for you to understand for instance, the solar radiation as well as the dynamics of the atmosphere. This is not what this is about. This is about a path, a travel through the history to understand actually when we understood where the problems was about the climate change, and the fact that when is it that we understood that the humans were behind this problem. It's not about adaptation, so it's not about the effect of climate. It's really in the interlinkage between the scientific knowledge and the actions that are coming from the policy. You will understand that it is a long time that we know all these processes, maybe even further than when you think. And then you realize also when the first movement from the policy point of view and political point of view came into place, and then try to bridge exactly the actions to what science was saying. We will see also what happened in the last years from the Paris Agreement on, and then as I mentioned, the last part will be dedicated to European policy on climate, and also what science, which input science provided to the policy to take place. And I started with a wonderful stripes there, which says wonderfully, in a very intuitive way, that indeed, in the last years, something happens there. And then I may not be even a physicist, but I understand that actually something is happening. And if we actually bring these stripes to life in terms of temperature, we'll see that it actually indicates exactly the changes of the temperature through, from the period in which the Industrial Revolution arrived. Now, in this field, we don't talk about the absolute temperature, usually. We talk about the anomaly of the temperature, so the difference between the actual temperature and a statistical value, a mean. And here we see the differences between the temperature, the global temperature per year on the average temperature of the 20th centuries. This is one of the ways to say it. You see also sometimes the temperature compared to the pre-industrial time. So it is a different ways to see the things. But also in this case, what is clearly seen from this graphic is 2023, we know, has been the hottest year since we started to make the measurements. And then the last 8 years has been the highest in terms of temperature for the recorded one. And indeed, we have 45 years of steady growing of this temperature anomaly. The other thing that you see there, also it is the yellow curve, which is the concentration of CO2. It is from Mauna Loa. I choose this because there is a special meaning historically with that place. We will see in a moment. But it's very, very indicative of the concentration of CO2 at the global scale, just because CO2 remains in the atmosphere so long that actually the concentrations are not that different from one place to another. While when we reconstruct this CO2 concentration, we have to take the course in the ice, and then we reconstruct this file. If you look at these pictures, you see that this growing of the temperature and the concentration of CO2 is going hand in hand. So they are growing together towards the highest value. We will come to that in a moment. So what we'll do today is to look exactly at this span of time and understanding how the science developed, what the science really figured out about the problem, and how started to feed in the policy action taking place. But before that, so before the industrial time and before science really started to play a role, the first one thinking that actually man could have a role in the changing of climate were the Enlightenment philosophers. And here we see two examples, so they were not the only one. So we are in the 18th centuries, a French cleric, Jean-Baptiste Dubos, and then the British David Hume. Both of them, even with a philosophical approach that was different, started to think that actually, first, the air was really a result also of the influence of soil and water. And then also the fact that if man was changing those soils and waters, certainly these could have an impact on the climate itself. They were not based on science, they were based on a philosopher thinking, but they're very close to, in reality, what happens. And in fact, the first really a scientist, a physicist, thinking about the climate change or the role of the atmosphere in climate, in the temperature, was exactly Fourier. Fourier made a calculation and then thinking about the solar radiation impacting our planet, and calculated that if we consider only the planet, the solar radiation impacting the planet, some of the solar radiation is scattered, is reflected back in the space, but another one is really absorbed by the soil, and then it comes back really in the infrared. And evaluate that if we consider this process, the average temperature of our planet would be -18. Luckily, it's not the case. Otherwise, we would never have had our life. And therefore, says, well, it's due to the presence of the atmosphere if this does not happen. Somehow, this layer is really providing us which are the conditions for the life to take place. Actually, in inventing the concept of the greenhouse gas effect, the greenhouse effect. And then we have to wait a few decades to understand which were the real actors within the atmosphere that were the reasons for this growing of the temperature or the climate of the atmosphere. And the first is John Tyndall, an Irish physicist, I think, which actually say, well, I know who actually does this. It is water vapor, and it is CO2, carbon dioxide. So they are the major reasons why this temperature is kept, because they are really interfering with the radiation, and this is the result. He's very well known, but in reality, the first that actually understood which was the process, it was a lady. It's an American lady, very little known. She was a scientist, more an amateur scientist, but in her lab, she was actually the first to understand that this is what was driving the climate issue, and also thinking that actually if CO2 was growing in the atmosphere, we could have been a problem. It is at the same time of Tyndall, they had an exchange of letters, but then he was the first actually, that probably the one that actually published the first, and then we know that this comes from him. And then another important brick of all this understanding of the role comes from the Swedish Svante Arrhenius. Svante Arrhenius does a wonderful thing. He's the first to evaluate, really, with mathematical calculus, the effect of CO2, and then understand that if we double CO2 in the atmosphere, it could really calculate the growth of the temperature. So it says that, well, the global temperature goes up by 5 or 6 degrees. This is a very important piece of information because it says how our planet reacts to this growing of the CO2, but also linking the presence of the CO2 in the atmosphere also to these interglacial and glacial changes. Now, what we know about this comes from the ice cores. We go back to 800,000 years, and then in this ice, we actually could reconstruct both the temperature as well as the CO2 changes. So they are not going hand in hand together, but we see that the temperature changes, which were natural, it was really due to the movement of our planet, were actually coming around 100 years before the changes of the CO2. So we have those cycles that we see, the glacial and interglacial area, but temperature was driving the CO2 out of the oceans. And then when, due to the movement of the planet, the temperature was naturally falling, CO2 remained in the atmosphere because its lifetime is hundreds of years. So then the temperature was going down slowly, following the decline of the concentrations of CO2. And this has been until now. One important thing also, so first, temperature changes were coming before CO2 changes, much before. Second, there were only 5 degrees of difference globally between a glacial and interglacial area. 5 degrees. So when we talk now about an increase of 1.5, 2 degrees, it tells us really what we are talking about. This is really a huge change. And another one, those changes were with the scale of 20,000 years. We see the changes before really in a matter of a century. So geologically, if we can say so, there is something different from the action of the man and now and before. And then finally, I'm also a modelist, so I love models, but I know very well that I can model everything, but I need something like in the measurements and in the monitoring to understand if my imagination goes in the right direction. And he actually put together a set of 200 stations that they were measuring the meteorological parameters already at the time. And already at the time, he discovers that actually there is an increase of the temperature. Very low, very slow, but there is. So something was really happening. And then also it calls from really the fact that, well, look, there is something related to the humans that are happening now. And then he also sees and put forward the fact that actually once emitted, CO2 was not any longer recycled by our planet, but was remaining there, which was really the problem. And then we close the theory of the climate change now are coming from these two men. Actually, the one plus, which was a Canadian scientist, which actually used for the first time a digital computing tool to make the first model for the climate change. And actually, he writes a wonderful paper with the theory behind and also made the first model calculations. And his calculations were exactly going into evaluating the effects of CO2 and once more really to putting the finger to men so much that he could really say, well, I tell you, you can expect to see a temperature rise of 1.1 degree per century if this goes further. At that time, it was understood that the oceans were able to uptake all the excess of CO2, but it was not the case. So there were no measurements yet of CO2, so they were speculating what was happening. But Revel finally demonstrates that no, oceans cannot uptake this excess of CO2, and this CO2 remains in the atmosphere. And as I said, all this before we had any means of measuring CO2, which comes by this guy, an American young guy at the time, Keeling, who, following and in collaboration with the previous scientist, starts a very important and a milestone work on science, which is the monitoring for the first time of the CO2. And it goes in Mauna Loa, that's why I've chosen that place, which is in the middle of the Pacific Ocean, so far away from everything. And what it discovers, that it discovered, first of all, the breathing of our planet. So these lines of CO2 were really the effect of the interactions between the concentrations and our planet, so basically mostly the vegetation. And then what he sees, which is important, that even after a few years that he was measuring CO2, these concentrations were already growing. So the problem was there. So it was true. In a way, he was able really to provide the ground for the ones just before him that they actually made the theory. all these, both of the theory, but the measurements of killing starts triggering some discussions on the action, because if it is true that we are confronting with an issue and a man is responsible of it, we need to do something. And the first policy reaction was actually from United States, which for a long time has been quite active in this, we'll see. And then Lyndon Johnson asked his scientific advisory committee to write a report generally on the environment. But for the first time, a policy report contains lines dedicated to the issue of the changing of the climate. And in exactly this report, there is the first point to say, yes, we recognize there is a problem. We recognize our action as human, and therefore, we think that if we don't do something, we are going really to be in trouble, also for what concerns the extremes. And now I want us to pause a little bit and look what we know now. So here on top, we know that the status of the scientific knowledge now, we know that CO2 increase from 1880 to 2000 is around 27%. By century, CO2 increase has been 36%. The temperature anomaly versus pre-industrial is 1, I think, and now is 1.1. And then the calculation, the current calculation of this doubling of the CO2, so the response of the planet to the CO2 is in the range between 2.6 and 3.5. This is what we know now with all the complex model that we are able to have. But this is what they knew at that time. It's not that different. Yes, we do a better job now. We are able to evaluate a lot of feedbacks. But it means that actually what they knew was covering exactly the basic knowledge of the problem. So the analysis done at that time with such a rough estimates that they could do was the right one. And this is really, to me, it was really quite revealing in terms of interest. So science finally made it through, because actually from the report of the United States, there are quite important, and the recognition of an issue, some important conferences were established. First, the United Nations First Earth Summit, and the first World Climate Conference, where all the knowledge that they had at that time was discussed. And then out of that, also because those conferences were really pushing the policymakers to take care of the issue, and United States in front on this pushing together with United Nations, finally agreed to call for a not interdisciplinary, but super partes body to be able to evaluate which was the science that it was known at that time, and then the Intergovernmental Panel on Climate Change was called to be born. So finally, science finds the recognition, and the policy recognized that science was important. At that time, United States, James Hansen, which was the director of the NASA Institute of Space Study at that time, had a very important hearing at the Senate in the United States. Actually, I met James, and he was still talking about this moment where actually he put on the table of the government and the Senate really the results of his work, which was with modeling. And then those work was saying, well, look, now we have basically the certainty, or really almost a certainty, that we are doing something completely wrong. And then if we don't do something, the effect on the extreme will be really terrible. In Europe, another important speech and another important support, policy support, to really face the issue from the policy point of view came from Margaret Thatcher. Margaret Thatcher she was a chemist, by the way, so she was really a believer that something wrong was happening and something needed to be done. So at the United Nations, she really pushed forward for all the nations to be together under one of the bodies of the United Nations, a framework in which really the signatories of the framework was really deciding to do something about it, really strongly. And then calling for a monitoring mechanism for them to say, hey, if you want to do it, you have to prove that you do it. And also to take the IPCC and the work of the IPCC really at the core of the policy. So really as an evaluation, super partes, really to help the policy to develop. So the first IPCC report comes in 1990, where they evaluate what was the temperature rise that was measured, and the fact that, yes, there was probably a human effect on the climate. But this report has been very important from the policy point of view, because it triggered the beginning of the EU policy on the climate change. In 1990, we didn't have the European Union yet, but we had already the nations under the European Committee at the time, where actually the European Council decided that we want to act. We acknowledge the problem, and we wanted to, by the year 2000, to go down with the emission of CO2 at the level of 1990, because of course it was already rising up also in Europe. And they put the basis of the policy currently present, like how do we do it? How do we decrease these emissions? Well, we have to use renewable energy, and we have to act on the energy efficiency, which are still the major two pillars of the European Union. And also put in place also, still present now, really a mechanism for the member states to report their measurements. And then we know IPCC really has published after 4 or 5 years, the new, or 7 years, the new reports. The last is 21-22, and then many of them are really fed through the different policy events. Margaret Thatcher called for the framework, and the framework convention was agreed. So we are at the beginning of the 90s, the United Nations Framework Convention on Climate Change, which is the one still present now, and the ones under which the COP famous are taking place, is adopted. And one of the first actions was really the decision to start working on a protocol, which has been the Kyoto Protocol. The Kyoto finished in 2012, had the characteristics that the different parties were really bounded themselves to a certain target for those emissions. So say European Union had its own, said, well, by 2012, I want my emissions going down. The United States was taking away. The decision of the president was not to join. But anyway, the year passed, and then after the Kyoto Protocol ended, the new discussion started, because actually it was important that the countries were again thinking to have another framework to talk to another protocol. And then we come to the famous Paris Agreement. The Paris Agreement concept in 2015 is a bit different than the Kyoto Protocol, because the targets are not for nations, but it is a target that is for the whole globe. So all the signatories together have a target of reducing the temperature to remain under the 2 degrees concerning the temperature increase from the pre-industrial time. And actually they wanted to keep the temperature rise even at 1.5 degrees. But to do that, we needed to pick the emissions really very, very close, and then going down pretty soon. And then it was important to have the climate neutrality by 2050. Climate neutrality doesn't mean emissions equal 0, but it means that at that moment, as much as I emit in greenhouse gases, I uptake from the atmosphere through, for instance, the carbon capture or another mechanism that we will see later. And also a transparency framework will put in place, because the countries need to say, well, I'm going to do this, and then this is evaluated, but it is evaluated really globally. From 2015 until now, other COPs came into play. And then what was always quite disappointing somehow was the fact that we didn't see really this strong commitment by the countries, the big emitters of the country, except the European Commission, which maintains the target really strongly. So we see the growing of the emissions, we will see in a moment. And then COP after COP, there were some elements which were interesting, like including funds for supporting the countries that are already paying for the climate change, but never really a commitment that was so strong in terms of actions until the last one, when anyway this commitment remained. And then, yes, commitments, but what is the situation about? So, and I started this with one of the things that we have. This is a global database for greenhouse gases. It's called EDGAR, Emission Database for Global Atmospheric Research. So what we do, and I go into this picture in a moment, what we do with this data is to inform our colleagues that works in the Director General for Climate when they have to go to the negotiation in the COPs. So they negotiate for the European Union, and then we'll give them year after year the new data. And what we see in this graphic is that unfortunately these emissions are really growing. Perhaps now we arrive to a point that perhaps is the peak, but not yet. Another thing that is interesting, we are not surprised, is the decrease, the year of the COVID, where many of the activities around the globe stopped, but we have not seen the same decrease of the temperature, or even in the CO2 concentrations, where we saw a steady line going up. And then which are the sectors that are important for these emissions? Which are the power sectors, part of the industry, the transport, the waste, agriculture, so there are many to act on. And then it's also interesting to see globally who is actually decreasing these emissions, which is not. And then our planet is divided basically into lines. The green line, the green parts above, so the countries that they have been decreasing their emissions, and the southern part of our planet, where of course the emerging countries are emitting more compared to 1990. And also, if we look at the increase of this concentration, or also let's focus our attention on the last line, which it disappeared here. So not the first where you see all the red lines, but the second, which is a more steady line for many of the sectors. Here is the growing or the changing of the emissions per sector. So we think we are going towards having the peak before going down. The situation in Europe, we know, is green. So except the traffic, which is one of the sectors that we have difficulties really to go down, all the other sectors are really doing pretty well. And then what about the emitters? So it's not a surprise that when we look at the results, China is the first, then we have USA, India, and the European Union, Russia, and all the others. And also it's not a surprise that when we look at the group of countries which are the economies, the large economies, what we see is that they emit more than the population that they have compared to the other countries. So we are the wealthy country where we are using these energies, and then we also emit. And then it's interesting also to look at the future. So this is another type of work that the JRC does year after year, also in preparation of the COP, what we do, our colleagues in Civil do, is an evaluation of the prediction of these emission trends for the future and the correspondent temperature. So this is what has been published last year. What we are looking here in black, which are the historical emissions, and then in pink, in purple, the first line above, it is the status, I mean, the current policies. So if we don't do anymore something really new, we are bound to arrive to a 3-degree increase by 2100. So way above the Paris Agreement target of 2 degrees. And then in the bottom, the yellow line is the line that we should achieve to remain below 1.5. And the rows in the middle, the dashed one and the other one represents the mid-term target. So this is an evaluation of the emissions. If countries are really applying what they have they promised under the Paris Agreement, considering only the target for 2030, so basically the day after tomorrow. But if we have countries where they have a long-term targets, and the European Union is one of them, but we'll see in a moment what I mean, we reach for the other rose line. Still is the one, more or less, that could keep us around 2 degrees, but certainly not 1.5. And now if we look on these green or orange points on the line there, represents the longer-term target. So for the European Union is the climate neutrality by 2050, but we are not the only one. There are other targets, as you can see. But what is the pointing, where the arrow is pointing, tell us where we are going. So EU is going towards the target, as well as USA, but certainly not China, not India, not the Russian Federation. So although these countries have long-term targets, they are not going in that direction. So there is really a problem here, and then we know it's really one of the issues that they are not able to face through the different COPs. Now, let's bound back to Europe and see the development. And also here we are starting in the last part of this talk, where again, I take the liberty to show you how we can provide science to our colleagues in Brussels. So here we are in the pre-EU Green Deal time. So before the last commission enters, exactly as from 1990, EU has the climate target, and it was 20% reduction of the greenhouse gases in 2020 versus 1990. We met the target, by the way. And then there was also a target for 2030 of a 40% reduction. And again, you see in the bottom how using exactly those two pillars of the energy and renewable. But in 2018, a very important IPCC report was published. It was actually the world at 1.5 degrees. This report, which is crucial, says exactly that if we aim, as the Paris Agreement wants, to 2 degrees, we don't actually protect at all our planet, not our systems, not the natural systems, and not the human system. And what we need to expect in that case is really a disruption, a severe disruption of some of the systems there. And what the Commission and EU decides to do is to revise the target and going in the direction to be able to meet the target for what concerns the Union of the 1.5 degrees. In 2019, the Commission, the new Commission at the time, published and adopted the European Green Deal, where these targets are indeed revised, actually based on that report. And then putting on the paper that not only the targets for 2030 are 50%, but we need to go into the climate neutrality by 2050. And it's not stopping there, because what it does is writing on an EU law that this is the target that EU is going to take. So the climate neutrality, and increases the target for 2030 to 55%, publishing a series again of tools to support financially and technologically this transition. So this is exactly what we know is beyond the green transition that has been taken up by the European Green Deal for the climate. And what have we done for this? Well, in the moment in which the European Commission decides that it is a time for the new legislation, it needs to have options. So he needs to know how, he needs to fix the target, and he needs to know how to get the target. He needs to know which are the paths that technologically, economically can really follow to reach for the target. But these paths need to be sustainable, and not only from the environmental point of view, also technologically, also economically point of view. So what our colleagues, again in Civil, they have published, they made a study with a series of different paths that was going into the target, and then put on the table those options, and then they do it really using complicated models, take into account economy, energy, land use, agriculture, and then they are looking also to side effects like air quality, not only the climate. And then they put these options on the table of the policymakers, and then the policy makes the choice. And this is the path that the Union has decided to take to reach for the climate neutrality by 2050. Those colored lines tell you exactly what is the expected changes, which are the different sectors that are expected to change, and how. Putting on the table all these framework of laws and legislation is quite a complicated work, and is taken really years, all these last commissions, but this is where we arrived. And then what is evident there, that there is a complete decoupling between the emissions of greenhouse gases and the GDP, so actually the economy of the EU. And then, of course, brings together a series of fundings and a series of changes, decision of which sector to do and which strategies to implement, decides which policies to put in place in terms of directives, which it is all the infrastructure of laws that has been really published during the last years. And then, of course, one of the elements of this neutrality of climate is indeed we needed to have sectors that are able to capture what remains in the atmosphere, because we are not able to decrease the emissions to zero. And then, therefore, also part of the laws is about how to make this grow. So we have the EU climate law fixing the 55% and the climate neutrality in the law. And in February, another recommendation from the Commission was actually published, fixing a mid-term target for this decrease at 90%. Why this is necessary? Because you need to govern the changes. It is a quite a strong change between 2030 and 2050. You need to govern it. But fixing this target, it doesn't, which is only for a recommendation, is not just fixing a number. It's like really to come with again, evaluations of how we spend our money as a European Union to have that happening. So, as I said, this is a recommendation, it's not a law, but the recommendation is done for the next commission that should come into service this year after the election. And what we have done for this 2040 target, we have made, again, another group of work for this, looking into the availability of the raw material for the transition to take place, looking at which are the technologies, because for us, we have to say, well, these technologies are really there, or they will be there, or to be there, you need to invest a certain amount of money in this sector or in another. And then also the effect on the economy. So what does it mean? Is it sustainable economically? The EU will be able to sustain economically this change. So there is also money for the poor group of people to make sure that this transition is really just, as we say, for everybody. And also, one of the points is really to make sure that we are able to have already by 2040 those mechanisms of removal of CO2 enough to start really to be ready to go down in 2050. The last slide is about a very important pillar of a policy, which is a citizen. Citizens are the ones that are going and choosing which is the policy or political people that are going to drive their life with their decision. And this is also an important point in the EU legislation. When the new legislation is coming, there is a survey for the public which is called Eurobarometers. And if you are interested in understanding how the public reacts to certain issues, there you find them a lot of interest in them. This is the one on climate, exactly launched in preparation of this 2040 recommendation. And then there are many questions. I picked up a couple. How serious is the problem of climate change for you? This pie you see around the average European citizen, and in the center, the Italian one. They are not that different, but for the citizen, it is a very serious problem, or at least a fairly serious problem. And what the citizen expects is action. Actions from their government, actions from still the European Union, action from the businesses industry that they have really to make this transition, and also for the rest. And then I would like to close all this saying exactly that I found always interesting to look try to understand. I don't think I've understood, except the fact that the issue is not one of the priorities, globally speaking, of the policymakers that has really the highest priorities, except the Europe, where all this really shows that is the case. But I think that is very important for us as a scientific community to understand what is our role. Although we didn't come where we wanted to be, we want to be protected now, we are not there yet. We don't see really this changing for the positive yet. But what we saw is really that the science has been the center of the change. In spite of this change is not that strong as we want. And this is also for you as a scientist to remember that we have a role in our society, which is yes, to conduct our science, but what we never forget that we can help to make the changes, and we have to do it as much as we can. I have the privilege, I had for 25 years the privilege to work in a place where science was really heard. And I saw the results. And this is really good. It happens. Maybe not always, but it happens. And therefore, I wish that some of you in your life, one day you decide, why not going to work for science in support to policy, maybe at the Joint Research Center. Thank you.